Hello guys, welcome back to another video. In this video, we will protect our power system from the overcurrent fault from the differential protection for both the transformer. So let's get started. I just built my power system that is from generation, from the transmission till the load, and I will protect each part. So here I am using two generators, generator number 1 and generator number 2. I am using this step up transformer and I am using this step down transformer, and also I am using a three-phase pi section that is represented by the transmission line, and I am using three loads. I will just click on each block so that it can easily be rebuilt. Double click on the block of three-phase source. The voltage phase to phase is 11 kilovolt, the frequency is 50. The rest of parameter are as it is. Double click on this. The phase to phase voltage is 50, the frequency is 50. This is my three-phase VI measurement block that will measure three-phase voltage and current. This is circuit breaker that will sense when there is a fault in my system and it will operate. It will just interrupt, sorry. The relay will sense and it will give a signal to this circuit breaker and it will interrupt. Make it close and click the external and click OK. This is the step up transformer. The parameter R is rating is 100 kVA, frequency is 50, the primary voltage is 11 kilovolt and the secondary is 33 kilovolt, and the rest of parameter as you can see over here. This is another VI measurement block. This is another three-phase circuit breaker. This is also a three-phase circuit breaker. This is a VI measurement block, and this is my transmission line represented by pi section. Double click on this. I keep the length 100 and the frequency is 50. The rest of parameter you can change by your requirements. These are the VI measurement block. This is the three-phase circuit breaker. This is the VI measurement block, and this is the step down transformer. Double click on this and let's go to the parameter. The rated is 100 kVA, frequency is 50, the secondary voltage is 33, the primary voltage is 33 kilovolt and the secondary is 11 kilovolt, and the rest of parameter as you can see over here. This is another three-phase VI measurement block. This is a three-phase source, and I am using three different type of loads. All three are the three-phase series RLC load. Double click on this. The phase to phase voltage is 11 kilovolt, frequency is 50, the P power is 1 kilovolt, and the QL and QC power is 50-50. Similarly, these are the parameter for load number 2, and these are the parameters for the load number 3. These three-phase fault blocks are used to generate a fault in my system, and the state generator will insert the fault. I am using this differential relay model for this transformer protection and this differential relay model for transformation of this protection, and this block represents the overcurrent protection of my power system. I am using two demux and two scopes for each VI measurement blocks. For example, let's consider this VI measurement block. I am using one demux and one scope. It will show me voltages of three phase and the current of three phase. Okay, and I also put a power GUI and I keep it discrete. This double click on this and just make it discrete. Okay, now I will run my simulation without any fault. The simulation is running for 1 second. It will take time. It is a heavy file. Okay, now just click on this, and this is my current of scope VI measurement number 1. These are the voltages. Similarly, for this VI measurement block after transformer, this is the voltages values and these are the current values. Similarly, after the transmission line, these are the current and voltage value respectively. After the three-phase transformer, that is step down transformer, the voltage and the current value are, as you can see, all these are the sinusoidal. Now if I just insert a fault in my transformer number 1, click OK. Now run this again. it completely it's run. As it can be seen that it interrupt the fault for a time of when it's generated. Now let's again remove the fault, and I want to generate a fault in my transmission line. Double click on this and generate a fault in this. Just run this again. And see the current values. As it can be seen that it interrupted by when the time is when there a fault occur, and this disturbance because of the RL nature of the transmission line. Now remove the fault again, and now at the end just generate the fault in this transmission line, transformer number 2. Click OK, run it again, completed. Just check the output voltages, and it can be seen that there is a disturbance in the transmission, the output is as well, but when there is a fault it interrupted, it sends and give a signal to this circuit breaker and it interrupt the fault. So now let's learn the logic over current relay. This is my over current relay where the input is the current value. As it can be seen by it is split by this via a measurement block. Double click on this. This is my relay logic. This is input of the current, and this is the discrete values, discrete RMS block, and this is demux blocks, and it will be compared with a pickup value of 2. If this value is greater than 2, it will generate a high signal, and it will latch by this SR flip-flop, and it will generate a high signal, and a high signal both of these SR flip-flop, and then one will be given to AND, for which the output will be 1, and this output will be connected to the circuit breaker. But double click on this signal attributes and make sure you make it boolean. Similarly for this, double click signal attributes and make it boolean, and this is a data conversion type. Double click on this and convert it to double, because the output of the AND gate is in a boolean 1 or 0, so convert it to the integer or double value. You need this data type conversion block. This is the terminator block, because I do not want to need the Q0 bar. This is the SR flip-flop. Now let's consider the differential protection relay logic. Let's explain you. One voltage value is given at the input number 1, and one input voltage value is given at input number 2. Input number 1 is the primary voltage, and input number 2 is the secondary voltage. So this is my primary voltage, and this is my secondary voltage. This is demux, this is discrete RMS, and I multiply here at a gain of 3, just because at a secondary side I am getting, because the turns ratio of my transformer was 3, and this is the sum block where I will find the difference between these two. If there is a difference between these two voltages, I will get the error at this point, and I will absolute this, because I need to get a positive values. Then the rest of logic as it is. I am comparing with my pickup value of 2. If these are greater than this, so it will generate a high signal in an AND gate, and after that it will give output to the relay. As it can be seen, then one output, the relay output is connected with this circuit breaker. So this was the complete tutorial how you will protect your power system from the fault by overcurrent, undercurrent, and the differential protection. I have already built each and every relay protection and logic in a separate videos. For that you can visit to my channel. So thank you so much